Okay, so today we're going to talk about the Pythagorean Theorem. And the Pythagorean Theorem is one of these things that only works with a special kind of triangle. And the type of triangle that it works with is what we call a right triangle. So these things right here are right triangles. They'll show you by this little symbol. And then there's some important things you should know about right triangles. Right triangles, like all triangles, have three sides. But two of the sides we just call like sides, because there's nothing special about those two sides. And it doesn't really matter which one you call B and which one you call A. Like A or B are interchangeable and it won't matter. The third side, though, gets a special name. The third side is always across from the right angle. So no matter what happens, it will always be across from this right angle. And the third side is going to be called the hypotenuse. That is a very, very, very important name that you should know. So across from a right angle on a right triangle is called the hypotenuse. That side will always be the longest side. And if you look at enough right triangles, we'll eventually develop this formula, which is that a squared plus b squared will equal c squared. This is what's known as the Pythagorean Theorem. That if we square both of these sides and add them together, they are the same length as this third side squared, or the hypotenuse squared. Let's look at a couple right triangles and see if we can identify the hypotenuse and then try to use this formula to help us. Okay, so first let's see if we can identify the hypotenuse of all these triangles that I've drawn. And again, the hypotenuse should be the side opposite of the right angle. So in this first one, the hypotenuse would be this side right here. On the second one, again, it's across from the right angle, so it would be this one right here. And on this one, again, it's across from the right angle, so it would be this side right here. Now let's say we were given some dimensions, and let's see if we can find the hypotenuse. So let's say that this side was 3, and this side was 4. Well, we've learned that a squared plus b squared equals c squared. That's the Pythagorean Theorem. So we know that this side, which is my long side, would be the hypotenuse, and we call that c. Let's plug this into the formula. So we know that 3 squared plus 4 squared would equal c squared. Well, if that's true, then we know that 9 plus 16 would equal c squared, and that 25 would equal c squared. Now, if you're stuck on how to solve this, think back to before and think about what thing cancels out a square. Well, that would be a square root. And so we would find, when we take the square root of both sides, that this would be 5 and this would be c. And that, right there, would be my final answer. Let's try another one. Okay. So let's label some sides. Let's say that this was 2 and this was 7. So again, we have the same type of thing. We know that 2 squared plus 7 squared should equal c squared, which is this long side. And we would do the same thing, so we get 4 plus 49, which would equal c squared. Then we would add these two things together and get 53, which equals c squared. And again, we would take the square root of both sides. And when you take the square root of 53, it doesn't give you a nice number. We could put that in our calculator. Whoops. Look at that, 53, and then we pick the square root, and again, it's around 7. And the issue also is 53 won't simplify. So this would be my final answer. Okay, so we're going to try to simplify those square roots as much as we can, and if we can't, we'll just leave them. Let's try one more. Okay, so here we go. Let's make this side 6 and this side 8. So again, we know that 6 squared plus 8 squared should equal c squared, which is this third side. Well, that would be 36 plus 64, which equals c squared. And that would be 100. Then I would take the square root of both sides and get that 10 is equal to c. So again, if you can simplify the square root, simplify the square root. If you can't, well then, you just leave it in the square root and try to simplify as much as you can. Let's look at if we don't know a side instead of the hypotenuse. So let's take a new example. Okay, so again, the first thing I want to do is to identify the hypotenuses. That'd be the hypotenuse for all three of them because it is across from the right angle. And now we want to figure out, again, what our missing side would be. So if we have to find our missing side for all of these, this time we would have some side that we don't know, we'll call it A, plus some side B, which would equal some side C. And so in this first case, that would be a squared plus 5 squared plus 7 squared. And we would know that a squared plus 25 is equal to 49. This time, we want to solve for a, so we want to get a by itself. So to get a by itself, we're going to subtract 25 from both sides. When we do that, we're going to get that a squared is equal to 49 minus 25, which should give us 24. And again, we're going to want to take the square root of both sides. When we do that, we'll get that a is equal to the square root of 24. But in this case, unlike the other cases, we could reduce 24 because we know what makes up 24. What makes up 24 is 4 and 6. So again, make sure that you write the radicals over them so that you don't forget. And the square root of 4 I know to be 2. And the square root of 6, well, I don't know what that is, so I just leave it. That'd be my final answer. Okay. Let's look at this next one. So in the next example, we would have a squared plus 5 squared equals 10 squared. And again, if you remember before, even though that these moved positions, the reason I didn't call them a different name is because a and b are interchangeable. So I like to always make a squared my variable instead of have a b squared in there. But you can make either one. And so what I'm going to do here is we're going to subtract 5, or we're going to evaluate all the things. So when we evaluate everything, we should get that a squared plus 25 is equal to 100. Then we'll subtract 25 from both sides. We'll get a squared is equal to 75. Then we'll take the square root of both sides and get that a is equal to the square root of 75. This again, 75 will break down. So we could break that down into 25 and 3. And we know that the square root of 25 is 5 and the square root of 3 is unknown. So that would be our final answer. Let's do this last one. Again, we know that we would have a squared plus b squared, which is 2 squared, equals 9 squared. And we'd get a squared plus 4 is equal to 81. And again, we would subtract 4 from both sides, and we'd get a squared equals 81 minus 4. So I'm going to do that really quick. Which gives us 77, and then we'll take the square root of that. And we'll get a is equal to the square root of 77. Now 77 doesn't have a nice square root, so we could leave it again, and this would be our final answer. Some questions are going to ask you to approximate it to 2 decimal places. If they want you to approximate it to some decimal places, well, you just throw it in your calculator. you hit the square root button, and you see what you get. So if we were to approximate this to 2 decimal places, it'd be 8.77, and this thing would round down because we have a 4. So our answer would be approximately 8.77. If you wonder why I have squigglies for these symbols, it's not because I messed up writing. It's because this is how you show an approximation. They're kind of squiggly equal signs to say, hey, this is approximately what my answer is. We know our answer isn't exactly 8.77 because square roots go on and on forever. Any type of word problem you get in this section, you want to really make sure that you draw out the triangles and you kind of see what they would look like. A lot of times even squares can have this property, so let's see a square that might have this property. A square that might have this property would look like any old rectangle that you draw. As soon as I draw a rectangle down the middle, you can see that I have two triangles. This would be my side A and this would be my side B. Same thing for those because they're the same length. And this would be my side C. And hopefully you can see the right triangles that are made. So whenever you're drawing these problems for either word problems, or they give you like a television and they want you to know the diagonal of the television, you should just draw them and then just try to find any side by using the Pythagorean theorem. And again, the Pythagorean theorem can find you sides, or they can find you the hypotenuse. Try some of the problems today.